The Indian defense establishment recently stunned the geopolitical world by walking away from the flagship stealth fighter programs of both the United States and Russia. Moscow aggressively pitched its fifth-generation Sukhoi Su-57, even offering full local production and a custom two-seater variant. New Delhi passed. Washington offered its F-35 stealth fighter, widely considered the most advanced operational jet on the planet. India passed on that too. The ongoing conflict in Ukraine exposed severe vulnerabilities in Russia's defense supply chains. India is already experiencing delays in acquiring spare parts for its existing fleet of Sukhoi Su-30 MKIs, making further reliance on Russian hardware a strategic liability. Purchasing American hardware involves citing strict international traffic and arms regulations agreements. This means Washington dictates exactly where, when, and against whom a jet can be flown, and they retain the ability to remotely ground the aircraft using a digital kill switch. For New Delhi, sovereign control over its aerial weapon systems is now the absolute baseline requirement. Meanwhile, in Europe, a joint venture between France and Germany to build a sixth-generation Future Combat Air System, or FCAS, collapsed. The partnership dissolved over bitter disputes regarding intellectual property and technology transfers. Developing a sixth-generation fighter requires upwards of $100 billion. France's domestic defense market is too small to shoulder that cost alone. They need a partner with immense capital and a massive manufacturing ecosystem, a role India will only fill in exchange for 100% technology transfer and total access to the jet's source codes. India is leveraging this European vulnerability to acquire the foundational technology required to build a completely independent aerospace industry. The FCAS is engineered specifically to render current fifth-generation stealth jets, like China's J-20, obsolete. It accomplishes this by operating as a highly integrated network of different combat assets. At the center of this architecture is the Combat Cloud. This is a quantum-encrypted network that instantly shares threat data across military satellites in space, nuclear submarines in the ocean, and ground-based radar systems. All of that sensory data is fed directly into the Indian pilot's helmet screen in nanoseconds. This enables the pilot to track and target an enemy fighter from hundreds of kilometers away without ever switching on their own detectable radar. The main jet never flies alone. It travels alongside a swarm of autonomous AI drones, known as loyal wingmen, that communicate with the human pilot. If the formation encounters a heavily fortified enemy air defense system, the pilot can command these drones to physically crash into the radar towers, clearing a safe corridor for the mission. The pilot transitions from a traditional dogfighter into a battlefield orchestrator, commanding a network of autonomous assets while remaining at a safe standoff distance. To maintain this status, the jet utilizes advanced broadband stealth. Metamaterial codes absorb radar waves, while an ionized plasma field masks the aircraft's feet signature from incoming missiles. Traditional fighters rely on finite internal missile bays. This sixth-generation system will feature directed energy weapons, lasers and electromagnetic pulses that use massive electrical output to fry enemy electronics without a physical explosion. Powering these energy weapons requires the massive electrical output provided by the 120 kilonewton variable cycle adaptive engine included in the French deal. This engine physically alters its internal airflow. During routine patrols, it operates like a commercial turbofan to save fuel. When combat begins, it shifts its geometry to produce raw thrust, allowing the jet to fly at supersonic speeds without relying on fuel-guzzling afterburners. Securing the source code for this engine provides the exact component required to power India's own homegrown stealth fighter program, the AMCA Mark II. Deploying a network-centric swarm architecture neutralizes India's long-standing strategic threat of fighting a simultaneous two-front war against China and Pakistan. The data advantage effectively cancels out any numerical superiority. At sea, carrier-launched variants of this aircraft will have the range and tracking capabilities to close the Indian Ocean, from the Malacca Strait to the Gulf of Aden. By setting up mass production facilities for the FCAS on home soil, India creates hundreds of thousands of specialized aerospace jobs. The cost per unit drops, positioning the country to export these aircraft worldwide. This shifts India's strategic posture from reactive defense toward dictating the technical standards of 21st century combat. However, defense experts warn that the sixth-generation concept is still unproven. Before sinking billions into the program, New Delhi must secure a legally binding agreement for 100% source code transfer to avoid simply acting as a cash machine for foreign contractors. Furthermore, India cannot allow its domestic fifth-generation AMCA project to be delayed while waiting for the FCAS to arrive in the 2040s. To navigate the capability gap over the next 2 decades, the Indian Air Force must rely heavily on expanding and upgrading its current fleet of French Rafales. If New Delhi secures these terms, the future of its aerial defense will be built on data, AI, and lasers, putting sovereign control of the 2040 skies into Indian hands.